In this lecture, we're going to make the player feel the weight of being hit by adding some screen shake to our camera. So this is an effect relating to our camera. So let's create a new script first of all. Let's go into our scripts folder and create a new C# script called camera shake. And let's apply this to our main camera. And essentially how this script is going to work is it's going to take the current position of the camera and just move it around every frame. So let's open up our script. Let's clean up our comments above start and delete our update method entirely. And this effect is going to be controlled by two parameters. So let's create some serialized fields of type float. The first one is going to be the shake duration. So how long is the effect going to last? And we can default that to maybe 1 second for now. And the second is going to be of type float, and we're going to call it the shake magnitude. So how far is the camera going to move? And again, by default, we'll set this up at 0.5, and we can always fine tune and adjust these numbers later. Finally, for our variables, we're going to want to know the initial position of our camera, because once we've finished moving it around, we want to set it back to where it started. So let's take a vector3 called initial position. And in our start method, we're going to set our initial position equal to our transform position. Now to get this effect working, we're going to be using a coroutine. This coroutine is then going to be called from another script. So let's set up that method first and have a public void, and we'll call this one play. So we'll have camerashake.play. All this is going to do is start a coroutine, and we'll call this coroutine shake. Now let's create our shake coroutine. So we've got an I enumerator called shake. And writing this coroutine is mostly going to be a challenge for you, but let's just look at the logic for moving the camera to a random position to start with. So we're going to be moving our transform.position, and this is going to be equal to our initial position plus a random dot inside unit circle. And notice here we've got an inside unit circle and an inside unit sphere. Since our game is 2D, the third axis doesn't really matter, so let's go with an inside unit circle. And a unit circle, if you're not aware, is just a circle with a radius of 1. So to give us a bit more control, let's also multiply that by our shake magnitude, and this will change the radius of that circle. Now this is giving us a red squiggly, and if we hover over it, it's saying that it's having trouble adding a vector3 and a vector2. Remember, our position is a vector3 and our random inside unit circle is a vector2. So we could either change this to inside unit sphere, or we could cast this to a vector3. And to cast a variable, we're just placing it inside parentheses before the thing we're trying to cast. And this will tell the compiler to treat this value as a vector3 rather than a vector2. And in this case, the third Z component that isn't in our vector2 is just going to be set as 0 in a vector3. So to explain this line in a little bit more detail, let's break it down in a slide. We start off with the camera in its initial position and then add a random point within a circle. This circle is starting with a magnitude of 1 being a unit circle, but then we're multiplying that by the shake magnitude, which gives us control over the area in which our camera can move. And then what we want to do is take our current line of code and place it into a loop, so that every frame we pick a new position for our camera to be. And if we move the camera around quick enough, it will make it look like the screen is shaking and not just being displaced every now and again. Then once the loop has finished, we want to place our camera back into its starting location. So this now brings us on to your challenge. I want you to complete our shake coroutine. If you'd like a couple of hints, then the camera should shake for the shake duration. So we're going to be adding some kind of loop in here, and you may or may not want a temporary variable to help control this loop condition. On every loop, once we've changed the position, we're going to want to yield control until the next frame, and we're used to waiting for seconds, but have a look and see what else we can wait for. Then once the shake duration has expired and our loop completes, we want to go ahead and reset the camera's position to its initial position. So pause the video now and give that a go. Okay, welcome back. So let's create the loop first of all. And to help with this, I'm going to create a temporary variable of type float called elapsed time. And we'll set this to 0 to start with. Then for our loop, I'm going to use a while loop because we don't know exactly how many iterations we're going to need. So let's say while the elapsed time is less than our shake duration, then we want to go ahead and continuously move our camera position. To stop ourselves getting into an infinite loop though, we're going to need to increment our elapsed time every loop. So let's say elapsed time plus equals our time dot delta time. And then finally, we're going to yield return a new wait for end of frame. So that will wait for the end of frame before coming back to our coroutine to check if it needs to do anything else. Lastly, once that loop has completed and our elapsed time is greater than or equal to our shake duration, we can go ahead and reset our transform.position to be equal to our initial position. So that's a very basic camera shaking script. And now let's look at where to call our play method. Well, I think a good place to this would again be in our health script. So let's jump over to our health script. At the top, let's create some variables. First of all, we're going to need a camera shake called camera shake. And I'm also going to add a serialized field here of type ball to check whether we should apply the camera shake. Because remember, the health script is attached to both our player and our enemies. And we don't really want this camera shake going off whenever we hit anything because it's going to be a bit too much. So instead, we're going to limit it to just the player. And this boolean will let us switch it off for our enemies. So with those variables set up, let's grab a reference to our camera shake script. And we can do this in our wake method. So we can say camera shake. And to find the component, we could go and find the object in the scene. But remember, the camera has a handy tag attached to it. And this tag allows us to say camera.main.getComponent. And the component we want is our camera shake. So that's just another way of doing things for our camera, because this camera.main already has a find object of type built into it. So now let's decide where to actually call this shaking camera. And again, like how we've got our play hit effect in our on trigger enter, we're going to do a very similar thing with a camera shake. So we're going to create a new method called shake camera. And then if we go to the bottom of our script, let's create a new void shake camera. And in here, first of all, we want to check that our camera shake does not equal null, so that we've managed to find it on the camera. And we want to check whether we should be applying this camera shake at all. If all of that is fine, then we can ask our camera shake to play. So let's save up our script and test this out in Unity. We can see here on our camera, we've got our two variables for our shake duration and our shake magnitude. And if we head over to our prefabs and look at our enemy, we want to make sure that the apply camera shake is switched off in its health script. And for our player, we want to go and make sure that it's on. Now, if we go ahead and hit play to test this out, let's get hit by an enemy and our screen shake gets applied. The effect is way too violent though, so let's tone it down just a tad. So let's come out of play mode. Let's go over to our main camera. And let's maybe reduce the camera shake duration to around half a second and the magnitude to around 0.25. Let's play again and test that out. And that screen shake is now much more subdued. But notice when we try and hit our enemies, the screen shake doesn't get applied, only when we get hit by them. And with that, we now have a nice extra effect in our game to help the player know when they've been struck by an enemy. Now, as a word of warning, I would caution you with using this effect too much because it can make players feel a little bit sick if it goes on for too long. And this is also a very simplistic version of a camera shake effect. If you'd like to play around with this effect and create something a bit more robust, then in the resources, I've linked to a fantastic GDC talk on this very subject. We went with this version in our project because it's fairly easy to implement and there's not really much math involved. But if you are that way inclined and you enjoy some math, feel free to check out that talk because it goes through some of the more complicated math that you might need. So congratulations on implementing this version of a screen shake effect, and I'll see you in the next lecture. In this lecture, we're going to make the player feel like they're flying through space by adding a parallax scrolling background. So, what is a parallax scrolling background? Well, if you've ever played any 2D games before, then you've almost certainly encountered this effect, and it's this effect here. So, what's going on here? Well, we have multiple different layers making up this image, and they're scrolling at different speeds. And by adding these additional scrolling layers, we can give an artificial sense of depth. This particular example, and the one we're going to use, only has 2 layers. But if you add more layers, then this will give you even more depth. And it's quite common to have maybe 3 or 4 layers making up the background and foreground for your game. Now, how do we get from what we've got now to what we want with our parallax scrolling? Well, first of all, we're going to have to break up our image because we've currently got this whole thing as a single image, and we're going to want to split this into 2 layers. Then once we've got our 2 layers, we can move one of the images quite slow in the background, and then add the other one on top, moving at a slightly faster speed. And notice here that the layers higher up in our order have to have some transparent areas to them or an overall transparency so that we can still see some of the layers beneath. If the top layers are fully opaque, then they're just going to obscure the bottom layers and the effect isn't going to work. So let's jump into Unity and see how we can do this in practice. Well, the first thing we're going to need is our 2 background images, and you can find these attached to the resources for this lecture. So if we head into our asset packs, I've already imported our stars 0 and our stars 1 image. Now later on, we will need to change some of the import settings here, but for now, the only one we really need to worry about is that the alpha is transparent. The reason I'm not going to change the other options that we definitely need to change in here is because I want to show you what happens when we forget so that we know how to troubleshoot it later on. So with our images in, let's drag them into our hierarchy. So let's take our stars 0 and drag it under our background, and then drag our stars 1 onto the background as well. Then we can go ahead and delete our star field because we don't need that anymore. And if all is well, then you should see the stars 0 on the back and stars 1 on the front. But you may be having some sort order in layer issues with the background and your ship and everything else. So let's go ahead and just set the order in layer for these up as well. Now we've got 2 options here. We could set the background onto its own sorting layer so it never interferes with anything else. But for now, I think we'll just change the order in layer. And remember, we've got projectiles on layer 0, ships on layer 1, and our explosions now on layer 2. So let's set our stars 0 to be order -2 and our stars 1 to be -1. And that should make sure that everything in our game appears on top of our background. Next, we're going to need to apply a brand new material to these 2 objects, because this is what's going to allow us to start scrolling the image on top of that material. So rather than using the sprite's default material, let's right click in our assets folder, create a new material, and let's call this m_background. In here, we need to change our shader from standard, and if we head down to unlit, and then transparent. With that set up, let's drag that material over to our 2 objects, so our stars 0 and our stars 1 in the hierarchy. And before we start to code, let me just show you how this is going to work and the problem that I left intentionally before. So the idea is that in code, we're going to take our texture from our sprite, and then over time, we're going to change the offset value. And if we change the Y offset, we'll see that the texture starts to scroll. But we do have a bit of a problem at the moment, and we can see that the texture is being stretched out. Now to fix this problem, we need to head in to our images. And if we look at the import settings, right near the bottom, we've got this wrap mode, and this by default is set to clamp. And what clamp does is as the texture moves, it will just take our top line of pixels in this case and extend them down. This wrap mode does have its uses, but for our case, we want to go ahead and change this from clamp to repeat. If we then go down and hit apply, we'll see that our texture is now appearing correctly. And if we click back on our material and continue to change the Y offset, we'll see that the texture now scrolls nicely. That's roughly what we want to do. So let's zero out our Y offset to put that back to 0. And now let's look at how to do this in code. For this, we're going to need a new script. So let's go into our scripts folder, right click, create a new C# script called Sprite Scroller. Then let's take our stars 0 and our stars 1 in our hierarchy and add that Sprite Scroller component. And now let's go ahead and open up that script. In here, we want to clean up our comments above start and update, but we do want both of these methods. For our variables, first of all, we're going to want a serialized field for our move speed. So this is going to be a vector2 to give us control over both the X and Y components of our texture. And we'll call this the move speed. Then, to make life easy when we're coding, we're going to need a vector2 to store the offset, so the amount of movement that we're going to do each frame for our texture. And we're also going to grab a reference to the material itself. So let's call that material. Now, I told you a lie before. We don't actually need our start method. What we need instead is our awake method, because the first thing we want to do in this script is grab a reference to the material we're going to be changing. And we can grab this material by saying material equals get component of type sprite renderer, because we're interested in the sprite renderer's material, dot material. Now in our update loop, this is where the magic is going to happen, and writing this is going to be a challenge for you. I want you to make our materials start to scroll. And as a hint, because this is quite a tricky challenge and we've not encountered all of the parts of it before, the general logic is that we're going to calculate the offset for this frame. So think about how we can use the move speed to create the offset for a given frame. And then I want you to modify the material.main_texture offset. So pause the video now and give that one your best shot. Okay, welcome back. So the logic here is just 2 lines of code, so I'm not going to create a new method for this. I'm just going to put it straight in the update. And the first step is to create our offset. And this offset is just going to be our move speed multiplied by time.delta time. So we're making the move speed frame rate independent. Then to apply this to our main texture offset, we're going to say material.main_texture offset plus equals the offset. So that is really all there is to this effect. If we save up our script and jump back into Unity, we can now go ahead and look at our stars 0. We close up our material because we don't really need to change that directly in here. What we're more interested in is our sprite scroller. So by having a vector2 for our move speed, we have control over both the X and the Y. But for my particular game, I'm only interested in the Y. And I'm going to move this around 0.1, so fairly slowly. Then to create some parallax, we can move over to our stars 1, head down to our sprite scroller move speed, and we're going to set the Y component to around 0.2, so it's moving twice as fast. If we then go ahead and hit play, we'll see that we now get this nice parallax scrolling background. If we click on our stars 1 and reduce the Y component down to 0.1, we get a static scrolling background. And we can also do some strange things like add some X direction as well. So with this setup, we can add multiple layers, and we also have very fine-grained control over the direction and speed that this texture is going to be scrolling. And with that, I think our game visually is now looking pretty good. We have a nice scrolling background to make us feel like we're flying through space rather than just hovering in position. We have explosions on our enemies and on our player, and when we get hit, we have a nice bit of screen shake. With our visual improvements now pretty much there, in the next lecture, we're going to start looking at adding some audio. So I'll see you there. In this lecture, we're going to start adding some audio to our game. Before we get into music though, we're going to start with our explosions and our firing effects. Now, the first step to adding any audio into our game is to find some to use. So this is going to be your first challenge, to find some audio that you like the sound of. Here I am on kenny.nl again, where we got our sprites from. And if we head up to assets, Kenny also has some audio. So if we filter by audio, I'm going to go with the sci-fi sounds pack. Once you've downloaded your chosen audio, we need to import it into our project. And I've placed mine under my assets pack, and sci-fi sounds. So I've got all of my Kenny sounds in here. And now let's think about how we're going to play this audio. There are many options for playing audio in Unity, depending on whether you're using sound effects or music and things like that. So let's start by looking at playing one-shot audio clips. And these are going to be audio clips that are instantiated into the world at runtime, exist for the lifetime of the audio clip, and then get destroyed. Up in our hierarchy, let's right-click and create a new empty game object, and let's call this the audio player. It doesn't really matter, but let's reset the transform to keep it tidy. And next, we're going to add a new script to this. So in our scripts folder, let's right-click, create a new C# script. Let's call this the audio player and attach that to our audio player game object. With that set up, let's open up that script and see what we need to write. Let's start by getting rid of start and update because we're not going to need them for this. And I said we were going to play audio clips for when we're firing projectiles and when the enemies are firing projectiles at us, and also whenever something takes damage. So when that explosion happens, we're going to have a nice explosion effect to go with it. To start with, let's just go through the shooting effects though, and then I'll leave the damage effect to you as a challenge. Now, because our audio player is going to be managing multiple different pieces of audio, it would make sense to separate up our variables using some headers. So first of all, let's add a new header for our shooting. And under this header, we're going to need two variables. We're going to need a serialized field of type audio clip, so the thing we want to play. And let's call this the shooting clip. And the second variable we want is again going to be a serialized field, but this is going to control the volume of our clip. So this is going to be of type float, and we'll call it the shooting volume. To give it a default value, let's set this to 1 to start with, which is full volume. And because our volume is going to range between 0 and 1, let's also add a range attribute to this. So we can say range, and then in parentheses, we can give it a lower bound of 0f and an upper bound of 1f. And this attribute will then constrain our value between those bounds. This also has another nice benefit of adding a slider to our inspector to make it really easy to use. So with our variables set up, now let's create the method that we're going to call from another script to play this audio clip. Because it's going to be called from elsewhere, let's go ahead and make it public, but it's not going to need to return anything. And we'll call this method play shooting clip. In here, the first thing we want to do is check whether our shooting clip has something assigned to it. So we can say if our shooting clip does not equal null, then we want to go and play this clip. And the way we play this audio clip is by saying audio source dot play clip at point. So what this method does is takes our audio clip and instantiates it into the world. This means we're going to have to give this method some parameters, and the first one is the clip we want to play. So this is going to be our shooting clip. From our tooltip, we can then see the next parameter is going to be a position in world, and to make the audio as audible as possible, we're going to place it directly in position of the camera. We can get the camera's position by saying camera.main.transform.position, and finally we want to specify the volume. So that is going to be our shooting volume. Now this line is very long, so let's break it up and make it easier to read. And that is all there is to this method. Now we need to work out where we want to call this method from, and we're currently dealing with all of our shooting behavior in our shooter script. So let's open up our shooter script. And in here, the first thing we want to do is grab a reference to our audio player. So let's say audio player, and we'll call it the audio player. Let's add an awake method. And in this awake method, we're going to say audio player equals find object of type audio player. Then if we carry on scrolling down our script, we're dealing with all of our firing behavior in this coroutine. And this coroutine is getting pretty messy, so we may want to break this out into multiple smaller methods to make it easier to manage. But for now, I'm going to leave it as is, but feel free to update yours if you prefer. And instead, I'm just going to add another new line in here. This line is going to be our audio player dot play shooting clip. So with that done, let's save our scripts and jump into Unity to test this out. If we check out our audio player, We can see how this header is going to come in useful for separating the different clips in our game. And we've also got this nice range slider between 0 and 1. Before we can play though, we do need to set up our shooting clip. So let's find our audio clips in our folder. And I'm going to choose the Laser Small 1 for my audio clip. Now in our game view, if we just extend this over so we can see some of the options, we need to make sure that mute audio is unselected. This can trip you up quite a lot of times. So if you've placed audio in your game and you can't hear it, then just make sure that this option is unchecked in the game view. With that deselected, let's go ahead and hit play. And we've got some nice shooting effects. Now this isn't too bad as it is, but with our rapid firing projectiles, this could get a little bit overwhelming. So let's turn it down a tad, because otherwise it can get very annoying. And I'm going to turn it right the way down to around 0.4. This seems like a much more reasonable volume, and hopefully you can still hear it on your end. So let's come out of play mode, and we made that change in play mode. So let's just reset that to 0.4. And now I think it's time for your challenge. I want you to go ahead and extend our audio player to play an audio clip when damage is taken. So when those explosions happen in our game. As a hint, it's a very similar process to playing our firing audio clip, so you can use all of what we've just done as a reference, and have a think about which script is handling the damage processing for our game. So pause the video now and give that a go. Okay, welcome back. So let's add our damage audio to our audio player. And it's so similar, in fact, I'm going to start off by copying and pasting my variables that I've already written. And I'm going to change my header to be damage. I'm going to change my audio clip to be the damage clip. And I'm going to change the volume to be the damage volume. Then we're going to need a method just like our play shooting clip. So again, let's just copy and paste this and reuse what we've got. We'll call this play damage clip. And we now want to say that if our damage clip does not equal null, then our audio source.playClipAtPoint should be playing our damage clip at the camera's position, and we want the damage volume. So that's all there is to this side of the script, but I'm noticing that these two methods are virtually identical. So it would be quite nice if we could simplify this in case we need to add any more audio to our game later on. So let's actually write another private method of type void, and we're just going to call this play clip. And if we look at the similarities that we can draw from both of our currently written methods, the things that really change are the clip and the volume. So our method can accept these as parameters. We need an audio clip, and we'll just call this the clip for now. And we need a float for the volume. Then we can say that if our clip does not equal null, then the first thing I want to do is try and shorten the length of this line of code. So I'm actually going to take the camera position as a variable. So this is a vector3 called camera_pos. And this is equal to our camera.main.transform.position. And then we can play our audio by saying audio source.playClipAtPoint. And we want to play our clip at the camera position at the specified volume. With our more generic methods set up now, we can use this in both of these other helper methods. So let's delete everything that's in there and just say play clip. And we want to play our shooting clip at our shooting volume. And for the second one, we want to play our clip, and we want to play our damage clip at our damage volume. So a little bit of annoying refactoring out of the way there, but we've now got a much more robust solution. With that all set, we now have to actually call this play damage clip from somewhere, and damage is currently being handled entirely within our health script. So let's open up our health script. At the top of our script, let's grab a reference to our audio player and call this audio player as well. In awake, we can say that our audio player equals find object of type audio player. And finally, in our onTrigger enter, when we're taking damage, playing our hit effect, let's say that our audio player should play our damage clip. So let's save this up now and jump into Unity to test that all out. In our audio player, let's set up our damage clip, and I'm going to go with Explosion Crunch 04. And if we once again hit play to test this out, we have our shooting sounds, and we have a nice explosion sound as well. Just like our shooting audio though, this may be a tad too loud, but until we get our background audio in, I think it's okay to leave it as it is for now, and then balance it later on. So congratulations on adding the first pieces of audio to your game, and in the next lecture we're going to start adding some background music. So I'll see you there. In this lecture, we're going to start adding some background music for our game. And the first step for this is to find some music for our game. So I've gone over to opengameart.org, which is a fantastic resource for indie developers. And if we head up to Browse and then down to Music, we'll have a whole bunch of music that we can choose from. Now we can narrow down our search with the search parameters on the left here. So first of all, I'm going to narrow down my license to look for CC0, so copyright free. We want some music as our art type. And if we have a rough idea of what sort of thing we're looking for, we may want to narrow down our search even further with themes and things like that. I actually got pretty lucky though when I was listening through some of these tracks, and in the very first one, in Chiptunes Action, I found some pretty cool music for my game. And the great thing about this site is that we can also preview our music before we download it. So we just hit the play button and we can hear our music. And this sounds pretty epic for a space battle, so I'm going to go with that track. And if we scroll down, we can select our files down here and we can download our zip file. Once we've downloaded that, we need to import it into our project. So I've dropped mine in the assets pack. So we've got our 5 action chiptunes in here. And we can also preview them in Unity. So if we click on one of our tracks and go down to the preview window, if you don't see the preview window, it might be closed up down the bottom like it is here. All we need to do is just drag it up. Then we can go ahead and hit the play button. And here's one of those other tracks from that pack. Now, before we start adding this music to our game, I've noticed that our asset pack is starting to get a little bit messy. We've got some materials in there in various places. So let's do a quick bit of housekeeping. I'm going to right click and create a new folder for our backgrounds. And we'll drag the star field, stars 0 and stars 1 into that. And then in the assets folder, I'm going to create a new folder specifically for our materials that we've been creating. So in here, we had the M background, so we can drag that in. And in our space shooter folder, we also had our M explosions. So let's drag that into the materials folder as well. That just makes them nice and easy to find and separates them away from the asset packs that we've been importing. So that's the housekeeping done. So now let's go over to our audio player and see what we did last lecture. We created this audio player script, which held an audio clip to be played and specified the volume that we wanted to play it. And if we open up our audio player, then we were using this audio source.playClip at point. But for our music, we don't really want this one-shot audio. We want it to be continuously playing in the background. So let's get a better idea of how Unity actually handles music in our game and understand what this audio source actually is. Well, the audio in Unity really comes in 3 parts. First of all, we need an audio listener, which is the thing that will allow us to hear the audio. And you may be wondering where that was sitting when we were doing this one-shot audio. And I'll show you where that is when we go back into Unity in a moment. Next, we need an audio source to play our audio. So that was that audio source.playClip at point. And again, I'll show you where that was sitting with our one-shot audio. And finally, we need an audio file, so the actual sound that gets played. So if we follow the arrows here, we have our audio file feeds into our audio source, and our audio source gets listened to by our audio listener. So let's jump back into Unity, and I'm going to hit play and pause very quickly. And if we play to the point where we have our laser being instantiated, we'll see that we've got this one-shot audio clip. And if we click on that one-shot audio, we'll find our audio source with our audio clip attached. So we were passing that audio clip from our audio player over to this audio source, and the listener for this audio source actually sits on our main camera. So if we look on our main camera, right near the bottom, we've got this audio listener. And that's why when we were playing our one-shot audio, we were telling it to play at the camera position for the clearest sound. So if we come out of play mode and go back over to our audio player, let's have a think about how we're going to play our music. Well, rather than mess with the audio player for now, let's go ahead and add a new component to this game object. And the component we want is an audio source. Now, this audio source has a lot of bells and whistles and levers that we can pull, and it may be a little bit overwhelming unless you've done any audio engineering in the past. But for us, we can actually ignore the vast majority of what's going on here. We're going to be playing 2D sounds, so everything in this 3D sound setting can be completely ignored, so we'll just roll that up. And the only things we're interested in is our audio clip, which is the thing we want to play. So let's go over to our audio and drag the clip we want into the audio clip. We don't need to worry about the output, and we can see here that it's expecting an audio mixer. It's a bit overkill for our game though, so we really don't need to worry about that. We have a mute option, so we can mute and unmute our audio. We don't need to worry about any of the bypass effects. For our music, we will want it to play on awake, so the moment the game starts, the music will start with it. But if we wanted to manually trigger our audio to play, then we could turn that off and then control that in code. And then finally, for our checkboxes, we have a looping option. And our music wants to be able to loop continuously through the game, so let's enable that. And hopefully for your music that you found, it is a looping track, so there won't be any hard cuts between the beginning and the end. Then down onto our sliders, we don't need to worry about the priority or the pitch or the stereo pan or any of that stuff. The only thing we really care about is the volume, so that's our normal volume slider like we've added to our audio player. And we could arguably pay attention to the spatial blend as well. As we can see, it goes from 2D to 3D. So what is that doing? Well, when we set it to 2D, the audio listener isn't really going to care where the sound is originating from. But in 3D, it will affect how loudly we can hear that sound based on where we're viewing it from the camera. So if you think about 3D games, if something's off in the distance, it's not going to be as loud as something that's right next to you. So not massively relevant for our game. The only thing we really need to be aware of is that it should be set to 2D. Now, if we go ahead and hit play, we should find that audio source with play on awake will start to play our music straight away. So let's hit play, and we do in fact get our music playing right out of the gate. And this has really drastically changed the feel of our game. For me, I think it makes the game feel a lot more exciting and as though we're going into battle against these invaders. So music selection is also incredibly important. So if we went with something more subdued, it would feel significantly different. So music choice is also a key part of your game design. So congratulations on adding music to your game. And with all of our sounds added, it's now time to start thinking about the user interface, because our player can take damage, but we really have no idea of how much health we've got left or how many points we've been scoring. We'll start our journey into that in the next lecture, so I'll see you there. Before we start worrying about the look of our future UI, let's first implement a scoring system so the player can see how well they're doing in the game, and also make a couple of tweaks to our health script so that we can show the player their current health. And because I think you're completely up to the task now, this is going to be a rather large challenge for you. So I want you to go ahead and write a public getter method in our health script to return the current health of the player. And then I want you to write a scorekeeper script which will attach to an object in the hierarchy. This script will have a private variable to store the current score. And because this variable will be private, we're going to need a public getter method to return this current score so we can send that off to our UI later on. We're going to need a public method to modify that score. And we're also going to want a public method to reset that score. And finally, for this challenge, we want to increase the score whenever an enemy is destroyed. So that again will be in our health script. So a pretty large challenge here, but pause the video and give it your best shot. Okay, welcome back, and a very big congratulations if you managed to do every single part of that challenge. If you didn't know, not to worry, we're going to go through it now. So the first part of this challenge was to make a public getter method for our health. So if we jump into our health script, we have our private health here. So let's just go and make a new public method, and I'm going to put that underneath my onTrigger enter. So I've got all of my Unity built-in methods together, my private methods together, and now our public methods. This is going to have to return an integer, and we're going to call it getHealth. And this is a very simple getter, so it's just going to return our health. So that's the first part of the challenge done. And now if we head into Unity, we're going to create our scorekeeper. Let's right-click in the hierarchy, create a new empty game object and reset its position. Let's call this game object the scorekeeper. And we're going to create a new C# script to attach to this called the scorekeeper. Let's drag our script onto our object and then open that up. For this, we're not going to need our start and our update methods, but we are going to need a private variable of type int to hold our score. Because this is private, we're going to need a public getter for this. So we'll have a public int getScore, and this will just return our score. With that set, let's give ourselves a way to modify this score. So this time we're going to have a public void called modify score. And this is going to accept a parameter of type int called value. So how much we want to modify this score by. And then to modify our score, all we need to say is score plus equals our value. Now we could get away with leaving this method as it is, but I'm going to do a little bit of extra work to clamp my score so it doesn't go below 0. So for this, we can say mathf.clamp. We want to clamp our score. We don't want it to go below 0, and we don't care how high it goes, so we can say int.maxValue. Finally, for this method, we wanted a way to reset our score, so setting it back to 0. So again, we'll create a public method of type void and call this one resetScore. And this method just has to set our score equal to 0. So congratulations if you managed to write all of that yourself. And the last step of your challenge was to increment the score whenever we killed an enemy. So if we jump back over to our health script, right at the top, we're going to need a reference to our scorekeeper. So we'll call this the scorekeeper. In awake, we then need to find our scorekeeper. So we can use find object of type scorekeeper. And because we're using this health script on both our player and our enemies, we want a way of separating these out so we're not adding a score when the player dies. So let's right at the top add a new serialized field of type bool, and we'll call this isPlayer. This will also have a use later on, so it's quite nice that we're adding it now. Finally, we're going to need to give these things a score. So we could potentially use the base health for this, but I think it would be quite nice if we had an independent variable for the score alone. So this is going to be type int, and we'll call it the score. And we can set this equal to maybe 50 to mirror our default health. But having these variables separate will allow us to potentially have a very low health enemy that's very hard to hit and therefore be worth a lot more points. So with our variables all set, let's head down to our take damage method, which is where our things with health are being killed off. And because we're going to eventually have a lot more stuff going on in this if statement, it would make sense to refactor this into a new method. So let's call this method die for now. A little bit morbid, but it does the job. And then we can create our die method where we can destroy our game object. Before we destroy it though, let's add our score to our scorekeeper. So we can say that if this is not the player, then we want to take our scorekeeper and modify the score, passing in the score for this object. And before we go and test this in Unity, let's jump back to our scorekeeper very quickly, because at the moment, until we've got our UI in, we have no way of checking whether this scoring system is working. So when we modify our score, let's just add a nice debug.log to tell us our score. So let's save up our scripts and jump into Unity to test now. Let's head over to our prefabs so we can look at our enemy and our player. If we look at our player first and head down to its health script, we want to say that it is the player, so it won't recognize any score. And because the score is mostly irrelevant, let's just set that to 0 just in case we forget to check our isPlayer flag. Then over on our enemy, we should have our isPlayer flag set to false, and we want to give it some sort of score, and I'm going to leave it as 50 for now. So if we click on our console, so we can see our score being logged out here, and go ahead and hit play. And now if we try and kill some enemies, we will get our score being logged out. So congratulations on creating that scorekeeper, and if you managed to do it all from the challenge, then give yourself a big pat on the back, because that wasn't a small piece of work. With all of that set up now, we're in a very good place to start adding our UI. We'll do that in the next lecture, so I'll see you there. In this lecture, we're going to start looking at building the UI for our game. Now, before we just jump into Unity and start adding things to a canvas, let's have a little think about what we're going to need to appear on this UI and where we're going to place it all. So let's bring up a screenshot of our current game so we can visualize what we're doing. And the first thing we're almost certainly going to want is to indicate the player's current health. Now, there are many ways to do this in a game such as this. We could go with a simple slider somewhere. We could potentially use something akin to heart containers. We could go with a simple text option to display the percentage of health or something like that. Or we could do something a bit more diegetic and potentially play around with the player's sprite. So we might have shield icons or damage that gets applied to the sprite itself. That last one is probably a little bit out of scope for the UI we're going to be working with. So for me, I'm just going to use a simple slider because we've seen those before and it'll be good practice to use them in a different context. After health, I think the second most important thing to display to the player is going to be their current score. And when it comes to displaying score in a game, there really is only one option, and that is text. Now for my game, I'm just going to stick with these two things, health and score. But if you want to expand your UI, then here's a couple of other things you might want to think about. You may want to add some information on the current wave or even potentially future waves. You may want to indicate whether the player has any power-ups they can use or whether power-ups have been activated. And if you're going with an endless runner style game, then you may want to add something like the playtime. So with thoughts on what UI we're going to include, now let's think about where we're going to place it all. And the trick with UI is it should be easily accessible but non-intrusive. So first of all, let's think about where the player's eye is generally going to be focused when playing our game. Well, I think it's probably going to be most focused around the area where our enemies are going to be, so around the center of the screen. But we do also have our player ship, and the player is going to be looking at that quite a lot. So with this general idea of where the eye is going to be tracking, it would make sense in this case to probably have our UI at the bottom of the screen. So with a general game plan in hand, let's jump over to Unity and start implementing this. So to add our UI, we're going to need a canvas. So let's right click on our hierarchy, go down to UI, and then add our canvas. When we add this canvas, we also get the event system for free. But if we click on our event system in our current project, we're currently getting a warning message. And this is because we're using the new Unity input system, and it's by default set up for the old system. This isn't going to be relevant for this particular scene because our UI isn't interactable, but because we will be using it later on, let's just go ahead and click on this Replace with Unity Input System button here. This will set up a bunch of stuff behind the scenes that we really don't need to worry about, but it will now allow all of our UI to be interacted with via the new input system. So with that set up, the next step is let's click on our canvas. And the last time we used the canvas, we pretty much ignored most of the stuff that was going on in here. But because we're not working with a fixed pixel size now, we're working with an aspect ratio, things are going to change based on how big or small our screen is. So the first step to making this function nicely is to change our canvas scaler. We can see that it's currently got a UI scale mode of constant pixel size. This isn't what we want though. We want things to grow and shrink based on the amount of screen real estate they're taking up. So let's change this to scale with screen size. This will then ask us for a reference resolution. So let's pick something that's in the 9:16 range. And I think maybe 1080 by 1920, so HD resolution, but on its side. With that set, now let's start adding some elements to our UI. And my UI is going to have three things. First of all, it's going to have a UI panel. And remember, this comes in absolutely giant in comparison to our game world. So let's double click on our canvas so we can see it all. And by default, this is already set to stretch regardless of what size our screen is. But we don't want this panel taking up the entire screen. So let's change this size a little bit. First of all, we're going to move the anchors, and there's a few ways to do this. We could change them with our anchor presets if we wanted to. We could change them manually by typing in the numbers we want, or in the scene view, we can click on the handles and start dragging them around. So I'm going to drag them down to be about 0.07, so about 7% of the total height of our screen. And then to fit the image inside of those anchors, we're just going to change the rect transform. And we can see the top alignment is negative 1700. So let's change that to 0. And now it fits nicely at the bottom of our screen. And if we go ahead and resize our game view, we'll see that our panel always occupies the same percentage of the screen. So anchors are really important and very useful for making sure elements stay where they're supposed to be. Now, inside of our panel, we're going to need two things. First of all, we're going to need a UI slider for our health. So let's call this the health slider. To set this into position, I'm going to break our anchors apart so that it fills the total height of our panel, but it only extends around halfway. Then let's reset the rect transform. And rather than allowing it to go right to the edges, let's add some padding. So I'm going to add a left padding of maybe around 25 and a right padding of around 25. This positioning looks about right to me. So then down in the slider, let's turn off interactable because we don't want the player to be dragging that slider around. We're not going to need any transitions, so we can set that to none. And to make it easier to see our colors that we're going to be adding later, let's just set the value around 0.5. Finally, because our slider isn't going to be interactable, we're not going to need the handle. So you can go ahead and either disable that or delete it entirely. Finally, for our UI, we want some score text. So let's again right click on our panel, go down to UI and then up to Text Mesh Pro. If we haven't already imported our TMP Essentials, let's go ahead and do that now. If you can't see this pop-up window, then just make sure that it isn't hidden behind another window or on another monitor if you've got a multi-monitor setup. And then once that's done, we can close our window. In here, we're again going to want to break our anchors apart. So let's scroll in so we can see a little better. So again, this is going to take up the full height of our panel and around half of its width. And to place our text in the center, let's change the left padding again to around 25 to bring it in a touch. Let's set the top to 0, the right to 25, and the bottom to 0. Then to arrange our text, let's go into our Text Mesh Pro element. And rather than giving it a fixed font size, let's select auto size instead. If we take a look in the auto size options, then we can set a minimum and maximum font size. So I'm going to go with a minimum of around 5 and a maximum I'll leave at 72 for now. And for the alignment, I'm going to go with a right middle alignment. And then, so we're not looking at new text, let's add some numbers into the box so we can see how they all look. To me, they do look a little bit rubbish at the moment because we are using the default Liberation Sans font, but with our elements now in place, it's time for your challenge. I want you to go ahead and improve the look of your UI. So for this, I want you to be thinking about the color scheme of your UI, and I also want you to find a nicer font for our score text. So pause the video now and work on the design for your UI. Okay, welcome back. So hopefully you had fun designing the UI for your game and picking a nice color scheme. While you've been away, I've set up mine in this nice blue and purple scheme. So let me walk you through the changes that I've made. So on my panel, the only thing I've really changed here is the image color. So I've gone with this nice purpley color. Over on our health slider, if we look at the background, I've reused that exact same color, but at full opacity. And for the fill, under the fill area, I've picked this nice blue color. Then over on the text side of things, I've gone ahead and found a nice font that I liked the look of. This again is from Kenny and it's called Kenny Space. Because we're working with Text Mesh Pro, we need to turn that font into a font asset. So remember, we can do that if we select our font. We can go up to Window, down to Text Mesh Pro, and then click on Font Asset Creator. select our font that we want to create, and then generate our font atlas. With that set, we're then able to drag that into the font asset section. And to create this outline effect, what I've done is rather than playing with the vertex color of the entire text, I've gone down to the bottom under extra settings in TextMesh Pro, and I've adjusted the face color to be that same blue color that we used for our health slider, but I've turned the opacity right the way down. And then I've added the same blue again, but as an outline at full opacity. I've added a thickness of around 0.25. And then to really make it pop, I've also added some glow. With our game UI now sorted, it's time to write some code to get all of this connected up. But to stop this lecture from becoming too long, we'll stop things there for now and work on hooking everything up in the next lecture. So I'll see you there. In the last lecture, we created the game UI, but it's not yet been connected up, so if we play our game, it doesn't do anything. So that's going to be our job for this lecture, and because I know you're up to the task, we're going to start off nice and early with a challenge. I want you to go ahead and write a new script called UI display, and attach this script to the canvas. Now this script should be responsible for updating all of our UI elements, so our slider and our score text. And remember that our health script contains the player's current health, so you'll need to utilize that. And the scorekeeper contains the current score. So pause the video now and give that a go. Okay, welcome back. So let's go ahead and create our UI display script. Over in our scripts folder, let's right click, create new script, and call this UI display. Let's drag that script over onto our canvas and then go ahead and open that up. To get us started in here, let's remove our comments above start and update. And because we're going to be dealing with UI components, we're going to have to add our two using statements at the top. We're going to need using Unity Engine.ui and using TM Pro for our TextMesh Pro element. Then for our variables, let's split these with some headers. And we'll make the first one elements relating to our health. And the second one will be elements relating to our score. Under our first health header, we're going to need two variables. So let's have a serialized field of type slider, and we'll call this the health slider. So that's the object on our UI. And then we're also going to want access to the player's health. So let's have another serialized field of type health called the player health. And the reason we are attaching this manually rather than finding it in the scene is because all of our enemies are also going to have health scripts. So for now, it really is just going to be easier to manually connect it in the hierarchy. With those set up, let's go under our score header and add another serialized field of type TextMesh Pro UGUI and call this the score text. And then finally, we're going to need the scorekeeper. So we'll call that the scorekeeper so we can grab our current score. Now we could go ahead and make this serialized as well, but since there's only one in the scene, let's just go and find it in a wake. So we can say our scorekeeper equals find object of type scorekeeper. Now before we start updating these elements in the update method, there's one more piece of setup we want to do for our health slider, and that is to set up its maximum value. We could do this in the inspector, but because it's linked to the maximum health of the player, it's probably a good idea to grab that from the health script when the game starts, so that if we ever change the player's maximum health during the design stages, the UI can just update itself. Then down in our update method, let's update our UI. So first of all, we can take our health slider.value, and that is going to be equal to our player health.getHealth. And finally, to update our score text, we can say scoretext.text equals our scorekeeper.getScore. And because that returns an integer rather than a string, we can say .toString to convert it. So with that set up, let's jump over into Unity to test things out. Before we can hit play, we do need to connect things. So on our canvas, let's scroll down to our UI display. Let's drag over our health slider. Let's drag over our player. And let's drag over our score text. This is currently labeled text TMP. So while we're here, let's also change this to score text to make it a bit more descriptive. And with all of that hooked up, let's go ahead and hit play. So if we resize our UI, we can see that it will adjust based on the screen size. We can see our health diminishing and we've died. So let's restart very quickly. And this time, if we actually shoot some things, when an enemy dies, we gain some score. But I'm not a massive fan of all of this blank space next to the score. So let's see if we can pad this out to make it look a bit more like our pre-visualization. Well, if we jump back over into our script, what we can do is we can pass in some parameters into our toString method. And to tell our game to always try and print a set number of characters in quotation marks, let's just give it 9 zeros. And now as we add score, it will add some leading zeros to the front of our score. So let's save that up, jump back into Unity to see this in action. And now, rather than a score of 0, we have 9 zeros. And now when we kill some enemies, we'll see that our score increases and our score text looks a bit more like those old-fashioned arcade LED displays. And personally, I quite like this kind of aesthetic with these sorts of games. You may be different though, so do feel free to format your score text however you prefer. And with that, the game scene itself is now pretty much finished. So congratulations on getting your UI all hooked up and working, and I'll see you in the next lecture. With our core gameplay now pretty much finished, it's time to start thinking about the other menus that we're going to add to our game. And if you remember, way back when we were designing this game, we said we were going to want two other scenes. We wanted a main menu at the start of the game and a game over screen at the end. So this is what we're going to start building in this lecture, and we're going to mainly be focusing on the UI for now. But in the next lecture, we're going to start hooking all of these up. So let's have a quick look through the flow now so we know what we're working towards. When the game starts, the player is going to be presented with the main menu screen. So it's got the game title and a couple of buttons. If they hit the quit button, then the game should just exit nicely. And if they hit the start button, then it's going to transition into our core game. Our core game will then proceed as we rack up some score and deplete our health. And when the health reaches 0, we then want to transition into the game over screen. This game over screen looks very similar to our main menu, and that's partly by design. But the big difference with this screen is it's also going to show the player their final score. So we are going to need a way to bring our score from our game over into this screen. And then for our buttons, we've got a play again button, which will launch us back into the game. So we get a nice loop here between our game and our game over screen. And finally, we have a main menu button, which will take the player back to the main menu screen, where they can either start the game again and go the long way around our loop, or quit out of the game entirely. So that's roughly what we're looking to build. So let's jump into Unity and start work on our new UI. And for these two menus, we're actually going to be placing them in new scenes in our game. So let's jump over into our scenes folder. And we've currently got our sample scene because we never bothered to rename it when we started our project. So before we do anything, let's rename that to something a bit more descriptive. We might go with, say, level 1, or I'm just going to go with game. And before we create a new scene and move over to that, let's also think about what's useful in this scene that we might want to reuse for the others. So let's jump into our prefabs folder, and all of our prefabs at the moment are mostly useless for our menu systems. But if we look through our hierarchy, then the background is probably going to be useful. So let's drag that down. We also have an audio player in here, and we're probably going to want music in our other menus. So let's drag that in as well. And finally, we did say that we wanted to bring our score from our game into our end screen. And whilst our scorekeeper doesn't do that yet, it will do later on. So let's prefab our scorekeeper as well. With our prefabs all set, let's go down back into our scenes folder. And to create a new scene for our project, let's right click, go up to create, and then down to scene. Let's give our scene a name. So let's start with the main menu. And now we can go ahead and open that up. We're getting a warning message because we didn't save our game before changing. So let's save our current game and then move over into our main menu. And this presents us with the ever so dreadful blank Unity canvas. So to make it pretty right off the bat, let's jump into our prefabs. let's drag over our background and our audio player. We don't want the audio player interfering with what we're doing though, so let's switch our music off for now. And then let's go ahead and create our new canvas. So let's right click in the hierarchy, go down to UI and then add a canvas. This brings in our event system for free, but remember we do have to change our standalone input module so that it works with the new Unity input system. So let's replace that. And because we've seen UI quite a bit now, this again is going to be a challenge for you to design and create our UI. But before we go ahead and do that, there is a couple of things that I'm going to be doing with my UI that I want to show you so that you have the option to do it as well. And the big changes come with our buttons. So let's right click on our canvas, go down to UI and add a button. And if we scroll down to our button component, this time we are going to leave our transition as a color tint. So let me explain what all of these color options are going to do for us. Let's start by going to our image component and changing the base color for our button. So let's create a kind of dusty red color. And now if we go ahead and hit play so we can see all of these in runtime, first of all, we have the normal color. And if the normal color is set to white, then the image color will take precedence. But we can also blend these colors by opening up our color picker. So we can see if we pick a minty green color for our normal color, then we get this muddy reddy green kind of color for our button. Next up, we have the highlight color, and this affects what happens when the button is hovered over. So let's create a nice bright orange color. And now if we hover over our button, it will make a blend between this yellow and red we've got. But now we've got an idea of how this color blending thing works. Let's actually set our image color back to pure white so we can see our colors in our button component unhindered, as it were. We can see that this has changed our button to our normal color of this minty green color. If we hover over our button, it goes to our yellow. And our pressed color does exactly what you think. When we press the button, it will change to this color. So let's pick a nice vibrant blue for this. And now we can hover over our button to get our yellow. We can press our button and it will turn blue. This is where our selected color comes in. So let's change our selected color to a purple. And now if we click back into our scene view, we have our normal color, highlight in orange, click in blue. And now if we move away from our button to get rid of that highlight color, we can see the button is currently selected in a very bright purple. Finally, in our list, we have the disabled color. This is currently set to a mid-transparent grey, and this is the colour that gets selected when we turn our interactable flag off. So setting up these colour tint options can be very important because it will allow the player to know what they've hovered over, what they've currently clicked on, and if things in the game are working as expected. So let's come out of play mode, and I'm going to delete the button that I've completely ruined. And now I think it's time for your challenge. I want you to go ahead and create a new menu scene if you haven't already, and then design the UI for our main menu. And then once you've got everything looking exactly how you want, I then want you to go ahead and create a new game over scene. And again, design the UI for the game over menu. Now, as a couple of hints, you may want to create some new font assets so that you can have different styles of text in your game. So if you want to differentiate between a title and subtitle, for instance, these will require two font assets, but they can of course use the same font underneath. And because our main menu and game over are so similar, don't be afraid to duplicate one scene to start working on the next. So pause the video now and give that a go. Okay, welcome back. So hopefully you now have two beautiful looking menus. Here's mine all finished up, so let me walk you through what I've done to create this. First of all, you'll notice that the stars are moving a lot slower in the background. So all I did to change this was go into the background in the hierarchy, and then under each of our layers, I've just gone down to our sprite scroller and slowed these down. And I did this because at the default speed, they were just a little bit too quick and quite disorientating for a menu system. Then over on the canvas, I've set up my canvas scaler to scale with the screen size and given that a nice reference resolution. And then inside of this, we've got the title text where I've created a brand new font asset using the same Kenny Space font. But for this one, I've gone ahead and changed the vertex color, and I've changed this to horizontal gradient to give me a nice two-toned purple effect. And if we look down in the extra settings, then the face and outline are the same as default, but I've added some underlay with a negative Y offset to give me this three-dimensional look. I've also added a little bit of glow to make it pop. And if we enable and disable these two options, you'll see the effects that they have. So our underlay is giving us that three-dimensional feel, and the glow is just brightening up those colors a bit. Under my title, I've added a subtitle. This one is reusing the same Kenny font from our game view for our score. All I've done is renamed it to Main Kenny to differentiate it from our title Kenny font. And I've stored both of these for reference in my asset pack under the Kenny Space font. So here you can see both of my font assets. Then for my buttons, I've placed these in a button group. So I've just created an empty game object and then added a vertical layout group. For spacing, I've picked a spacing of around 25. And then rather than resizing the buttons manually, I've used this control child size option for the width and height. This will force the buttons to fill the space of this game object. So if we change the size of this box, then the buttons will always try and completely fill it. If we open up this group so we can see the buttons themselves, I've got a start button and a quit button. And underneath these, they have the Text Mesh Pro elements. For the text, this again is copying exactly the same main Kenny font that we've been using, but on the buttons themselves, if we look at the button component, then I've added some highlighting colors and some pressed colors. So when we highlight a button, it will turn purple. And when we press on a button, it will go blue. So that's my main menu scene. And then for my end screen, once I'd finished this and saved everything in my scene, I went over to my scenes folder. I duplicated my main menu with Control D, renamed that scene to Game Over. And if we open it up, really all I've done is changed the title text to Game Over and the subtitle text to Better Luck Next Time. And then I've moved this up slightly to make way for my score. So if we look under the canvas again, I've now got this score text as well. And again, this is just reusing our main Kenny Space font asset. So if we play this scene, we can see the stars are still scrolling nice and slow, and the buttons are highlighting nicely. So congratulations for making your main menu and your Game Over screen. And in the next lecture, we're going to start looking at how to connect these buttons up and link scenes together. So I'll see you there. In this lecture, we're going to be making a level manager to allow us to connect up our three different scenes. Now, the first step in doing this is to do a little bit of extra setup in Unity. So if we head up to File and then down to Build Settings, we can see at the top here, we've got this scenes in our build file. By default, this will already include the scene that came with creating the project itself. This is usually called sample scene, but remember we renamed ours to game. And we can see in this list, we have the scene name on the left, and we also have a build index on the right. Now, since we've added some additional scenes for our main menu and our Game Over screen, we're going to need to add these to our build queue. So we can do this by just dragging over the scenes into this list. And we can see that over on the right, they've been given their own unique build index. Our scenes aren't currently in the correct order for us though, because when we start a Unity game once we've built everything, it will always load the index 0 first. So we're going to need to reorder the elements of our list and put the main menu first. That's incredibly easy. We just need to click and drag. Once we've done this, we'll notice that the build indexes have all changed. With that set, we can now close this window down. We don't have to hit any of the buttons at the bottom, just the X at the top. And now let's create a new level manager. So over in the hierarchy, this is going to be a game object that exists in the world. So let's create an empty object called level manager. And we'll reset the transform. Then over in our scripts folder, let's create a level manager script. So right click, create new C# script and call this the level manager. And then we'll drag that onto our game object. Finally, let's open this script up and start doing some coding. For this script, we're not going to need our start and our update method. But what we are going to need is at the very top of our script, we're going to have to include using Unity Engine.scene management, and that will allow us to start loading scenes in our script. With that set, now let's look at how we're going to load our new scene in code. And to start with, let's look at loading the game scene so we can attach that to the play button on our main menu. So we're going to want some public methods. These are not going to return anything. And we'll call this first one load game. In here, we want to take our scene manager, which comes with our scene management package, .load scene. And if we take a look at the tooltip, we'll see that there's a whole bunch of overloaded versions of this method. However, it really comes down to whether you want to load your scene by name or by build index. So we have two real options there. So to load our game scene, we may want to pass in the build index of 1, because remember it was the second item in our scene list, or we could reference it by name. So we could just write in the name of the scene. For simplicity and readability of our code, I think we'll stick with the string reference for now. And that is pretty much the end of this method, which I think would bring us nicely on to your first challenge. I would like you to write a couple of extra public methods. The first one will load the main menu, and the second will load the game over scene. So pause the video now and give that a go. Okay, welcome back. So hopefully you got on well with that first challenge. So for our first method, we can make a public void called load main menu. And this is going to take our scene manager .load scene of our main menu. Then for our second method, we want a public void called load game over. And this will take our scene manager .load scene of our game over scene. So hopefully that was pretty straightforward. But before we finish up our level manager script, there's one more thing we need to do in here. Remember that on our main menu, we also have a quit button. So let's add that functionality into this script as well. For this, we can have another public void method called quit game. And to quit out of a Unity game, we need to say application.quit. Now, this is a pretty hard way of quitting out of an application, and depending on your platform, it may or may not work as intended. If you've got a normal standalone build for your game, then this should be fine. But if you're using a WebGL build, then application.quit won't do anything because you can't quit out of an embedded web page. And if you're working on mobile, then there may be a couple of other things you want to do in here before just hard exiting the application. And because we won't see this working in our editor, let's also add a debug log in here just to let us know that we're quitting the game. So with that set, let's save our script and jump over into Unity. And now let's start thinking about how to connect this level manager up. Well, the first thing we probably want to do is prefab our level manager, because this is going to have to exist in all of our different scenes, kind of like our audio player is at the moment. So let's drop that into our prefabs folder. And then let's connect our start and our quit button on our main menu. If we click on our buttons and scroll down, we can add an on-click event. So let's add the plus icon to add an event. Let's drag over our level manager. And then in the drop-down menu, we can click on level manager and then load game. And for our quit button, it's very similar. We're going to add an on-click event, drag over our level manager. And this time we're going to go to level manager and then quit game. So before we set up the other scenes in our game, let's click on play just to see this in action. So if we look at our console and hit the quit button, then we get our quitting game message. And if we hit the start button, then we load into our game. Now from here, nothing's going to happen. So when we die, we're just going to die. So the next steps are going to be to call our level manager from our health script when our player dies, and also connect up our game over screen. So let's look at our health script first. And since we're going to need to add a level manager to our game scene, let's load that up. Remember to save your scene before changing. And with that loaded, let's drag in our level manager and then open up our health script. In here, we're going to start by finding a reference to our level manager. So let's say level manager, and we'll call it the level manager. In awake, we can find our object in the scene. So we have level manager equals find object of type level manager. And then down in our die method, where we're processing what happens when something dies, we're checking if we're not the player and then modifying our score. But if we are the player, so else, we want to say level manager dot load game over. And now when we run out of health, it will load us into our game over menu. This now brings us onto a second challenge for you, and that is to connect the menu buttons in the game over scene. So take what we learnt from connecting up the main menu and apply it to our game over menu. Pause the video now and give that a go. Okay, welcome back. So here I am in our game over scene. The first thing I want to do is drag over my level manager into the scene. And then on my canvas, we just need to go to our button group, click on our replay button, scroll down to our on-click event, add a new event, drag our level manager over, and then in the drop down, we want level manager.load game because we want to reload the game scene. And then on our main menu button, same process. So add an event, drag over our level manager, and then in our drop down, we want to load the main menu. So with that all set up, our game should have a nice flow between the different states of our game. If we jump back to our main menu scene so we can start from the beginning, if we go ahead and hit play, we can now start our game and play as we normally would. And if we take enough damage and die, then we load into our game over scene. And we can either hit our main menu or play again. And I would encourage you to go through all of the different combinations to make sure everything's connected up. But one problem with this scene is that our score is not being transferred over to our game scene. So that's still on our to-do list to fix. And listen to the music when we change our scene. It skips and starts again, and it would be really nice if it would continuously play throughout those scene transitions. The final problem that we're going to fix in this particular lecture is that when we die, we instantly get teleported to the game over screen, and it would probably be nice to have a little moment of pause before that happens. So let's come out of play mode, let's go into our level manager and open up our script, and I want you to have a think about how we might delay loading this game over. Okay, so if you answered a coroutine, then you would be right. So let's add a coroutine to our level manager so that we can delay the loading of this game over. At the bottom, let's create an I enumerator for our coroutine, and we'll call this wait and load. And to make this as generic as possible, in case we want to add more scenes with a load delay, let's pass in a string reference for our scene name and a float for the amount of delay we want to wait. And this method is really going to be as simple as waiting for the delay time and then loading the new scene. So we can say yield return, new wait for seconds, and the seconds we want to wait is the delay. And then once that time has elapsed, we can take our scene manager.load scene, and we want to load our scene name. So with that set, let's change our load game over. And rather than calling load scene here, let's call start coroutine, wait and load, passing in the scene name. And then rather than hard coding a value in here, let's pass in a variable name. So we'll add this to the top of our script in just a moment. But let's call this one scene load delay. This is going to give us some red squigglies because our variable doesn't exist yet. So let's copy this name and go right to the top. And let's create a serialized field of type float and call it the scene load delay. And let's maybe give this a default value of 2 seconds. We're still getting a red squiggly, and well done if you've spotted that I've missed a closing parenthesis. So now let's go back to Unity and test this out. And if we click on our level manager, we can now see we've got this variable available to us. Now do be very careful editing this value because it does only apply to this version of the level manager. So rather than changing things in here, it would be a better option to probably change the prefab version instead. But with that warning aside, let's go ahead and hit play and test things out. We can hit our start button to load our game. And if we die from our enemies, then we'll have a short delay before loading into our game over scene. So congratulations on hooking up your level manager. We now have a very simple way of transitioning between our various scenes. With that set, the next problem we're going to tackle is to get our audio playing continuously throughout the different scene transitions. We'll start that in the next lecture, so I'll see you there. In this lecture, we're going to solve this pesky little problem with our audio player, where when we change the scene, the track restarts. And we're going to fix this using something known as the singleton pattern. So before we talk about the singleton pattern, let's actually understand what's happening in our game. In our main menu, we have all of the objects that exist within this scene, including our audio player. But if we go ahead and hit play, and then change our scene by hitting our start button, everything from that original scene is being destroyed, and then everything from our game scene is being loaded in. So our old audio player gets destroyed and we create a new one. And in creating our new one, we start playing our track from the beginning. So we're going to need a way of grabbing our audio player from our main menu scene when the game starts and pulling it across into other levels of our game. And if we turn to the Wikipedia article for the singleton pattern, it says that the singleton pattern is a software design pattern that restricts the instantiation of a class to one single instance. And this can be very useful when exactly one object is needed to coordinate actions across the system. If we continue to read though, it does also say that it's considered to be an anti-pattern and is frequently used in scenarios where it's not beneficial. And that's because the true singleton pattern not only requires us to only have a single instance of an object in our game, but also that that instance is globally available to everything that needs it. And having global or public variables in our game can cause us some problems, especially when we're using the singleton pattern. So we have to be very careful about how and when we use it. But if we jump back into Unity, I'm going to show you two different ways that we can use this singleton pattern. The first, we'll create a single instance of our audio player, which will persist across our game, but not be publicly available. And the other one will be a more traditional singleton pattern, which does have global access. So to get us started, let's go over to our audio player and then into our audio player script. And to set up the non-global version, we're going to do all of this in Awake. And in here, we're going to call a method that we're about to write called manage singleton. Then underneath our Awake method, let's write this method, which is going to also be void. And we're calling it manage singleton. And we currently have an audio player in every scene of our game. So we're going to have to do a couple of things. First of all, when we load into the scene, we want to check if an audio player already exists. And one way of doing this is to use find objects of type. So just like find object, but with objects, plural instead. And rather than using the chevrons like we're used to, we're actually going to use parentheses this time. And we're going to say get type. What this get type does is it will return the type of the class that we're looking at. So in this case, it will be an audio player. So we could instead look for audio players instead of get type, but this is a bit more generic so that if we want to use this in other scripts, we can just copy it in without having to amend too much of the code. So this as it is will find all of the objects of type audio player. And from here, we want to find the length of this list. Now, this length is going to come in useful, and to help us get rid of the red squiggly error, let's store this in an integer variable called the instance count. So this will keep track of how many instances of our audio player exist when we load a scene. From here, we can then ask that if the instance count is greater than 1, then we've got more than one audio player in our scene and we need to start getting rid of them. And we can get rid of objects by just destroying them. So we can say destroy game object. And that's the game object with the lowercase g. Otherwise, if we don't have more than one audio player, we want to set this audio player up so that it can transition between our scenes and not get destroyed when a new scene is loaded. So to do this, let's say else don't destroy on load and pass in this game object. This will then mark our audio player so that when we change scenes, the existing audio player will come with us. So that's one way of doing it, but I am noticing a very small problem, and that is that before we destroy a game object, we also want to set our GameObject.setActive to false. Now this might seem a bit redundant because we're literally about to destroy it, but because of the way Unity executes its code, there's a very, very small chance other objects in our game may try and access this version of our audio player before we go and destroy it. So by disabling it in awake, we're stopping anything else trying to grab it and use it before we destroy it. Now, to see this in action, let's save our script and head over into Unity. And now if we go ahead and hit play, everything should work as it did before. But if we hit start, then the music continues to play. And if we look in our hierarchy, if we expand our game and let's pause for a moment, we'll not be able to find our audio manager in our game anymore. And that is because it's now under this don't destroy on load header. So this audio player in here is the audio player from our first scene rather than our current scene. So with our audio player working as expected, we could leave things there, but I did say that there was another more pure way to write a singleton. So let's jump back over into our audio player script and have a look at how we might do this. Well, it's actually going to be fairly similar, but rather than trying to find objects of type and then checking how long that list is, we're going to store a variable at the top of our script. It's going to be of type audio player in this case, so we're storing a reference to our own class type, and we'll call this the instance. And to get this working how we want, we're going to also add a new keyword in front of our audio player. So just like how we can have public or private, we can also have some other keywords as well. And one of those keywords is something known as a static. So this is currently a private static audio player. And static variables are interesting because they persist through all instances of a class. So if we had multiple audio players in our scene, they would all share this exact same static instance. This is great for our singleton. So in our manage singleton method, let's just comment out the first 2 lines for a moment. And we can instead say that if our instance does not equal null, then we want to go ahead and destroy the game object that's trying to create itself. Otherwise, we want to set the instance variable equal to this object. So we can use the this keyword, which indicates this version of the audio player. So the logic here is that if we're the first audio player to come along, then our if statement will be false, and we'll set ourselves to be the instance of this static audio player. Otherwise, if we're the second or maybe third one to come along, then our instance variable already has a version of an audio player stored in it. So we know we're not the first ones to come along, and we can go ahead and destroy ourselves. This instance, though, is still private, so if we scroll up to the top, a true singleton pattern would have this instance be public. So we could do this by either setting this to be public, but we would then have to worry about other scripts coming in and changing what this instance is, or we could create a getter, so a public audio player get instance, and this would just return our instance. Making this global as it is gives us some benefits that we can now reference the instance of our audio player dot any of our public methods. This means we wouldn't have to explicitly find our audio player in the scene first. We could just reference this static instance and have access to all of its public methods. To show you what I mean, if we head over to our shooter method very quickly, we're currently saying audio player dot play shooting clip. And we're able to do that because we've already found a reference to the audio player in our scene. But if we wanted to bypass all of this storing variables and finding things in awake, we could instead just say audio player dot get instance dot play shooting clip. And that would bypass any need to find that object in the hierarchy. So a couple of good benefits there, but also a handful of drawbacks which we haven't really discussed. By doing things this way and having a public instance available, we start to lose control of exactly where things are in our game. This is mostly fine for a small project like ours, but as your game gets much larger, you can have a lot of things interacting, and trying to hunt down problems with singletons is an absolute nightmare. So where possible, always try and avoid globally accessible instances if you can get away with it. For our audio player, we definitely can, so let's not do things this way. And back over in our audio player, we could keep our static instance if we wanted to. And in fact, I think we will, but we won't create the public getter method for it. Then down in manage singleton, let's just clear out those 2 commented lines of code that we don't need anymore. And now if we jump back into Unity, just to make sure that everything is still working as expected, let's go ahead and hit play. Our audio player is now in Don't Destroy on load and our music has started. If we change scene, our music continues to play and our audio player is still there ready and waiting for us. So there's two slightly different ways of implementing the singleton pattern and also how to make it global if you ever wanted or needed to do that. And with this knowledge of singletons in hand, the next step is going to be to look at other objects in our game that may or may not benefit from also being singletons. So no challenge for this lecture, but before you go on to the next lecture, just have a think about which objects you think might benefit from being a singleton. And then in the next lecture, we'll start looking at some of the other problems that still exist in our game. So I'll see you there. In the last lecture, we turned our audio player into a singleton so that when we changed our scene, the music would continue to play. And during that lecture, I also asked you to think about some other objects that may benefit from being a singleton. So hopefully you had a good think about that question, and there are a couple of different answers depending on the approach you're taking. One valid option is that nothing should be a singleton, and there are better or different ways of approaching our code to make sure we don't use them. But assuming we do want to add some singletons to make our life a little bit easier, the first candidate would be our level manager. Because we've got one of these in every single scene, they're all doing exactly the same thing, and we only ever really want one of them at any given time. But since having multiple level managers in a scene is not really going to break anything, it's not essential that only one ever exists at a time. The only real benefit I can see from making this a singleton is if we make it a pure singleton and have global accessibility, so we only ever have one in our entire game, because we can then stop worrying about this scene load delay in our hierarchy. Because if we change this in our main menu, it's not going to translate over into our game scene at the moment, so we could potentially change things in the wrong place and it will become a bit of a nightmare. But for now, the way I said we can get around this is just to remember or add a tooltip maybe to our script to tell us not to edit this in our scene view, and instead only change it on the prefab version. So as long as we haven't overridden it somewhere, it should update everywhere. Turning our level manager into a singleton would also create some other problems that we would need to solve, like how our canvas buttons are currently linked up to our level manager. So if we start moving that between scenes, we're going to have a script attached to our canvases to allow our buttons to find the level manager that's in the scene at a given time, and then hook themselves up. So it's going to create more work than we really want to do, so let's leave our level manager alone because it is working perfectly fine as is. But the other candidate for a singleton, which I think we will pursue, is going to be our scorekeeper. Because we currently have a scorekeeper in our game scene for tracking our actual score during play, and our game over scene for displaying the score at the end. Our scorekeeper needs a way of transferring that score from one scene to another, so it would make sense if the same object got carried across. And we also want to make sure we don't end up with more than one scorekeeper in a scene. If we ended up with 2 or 3 scorekeepers in our game scene, then every time we scored points, we'd be scoring triple the points. So our scorekeeper is going to make a good singleton, I think. But before we go ahead and set up our script, let's just do a little bit of extra work on our canvas so that we can find our score text and update it. So over on our canvas, we're going to add a new script. So over in our scripts folder, let's right click, create a new C# script. And I think we'll call this one the UI game over. Let's drag that onto the canvas and then open it up. And if you fancy a bit of a mini challenge, then go ahead and write this script completely on your own. And I'll give you a moment to pause the video if you want to do that. Okay, so if you did this as a mini challenge, very well done. Or if you want to follow along, that's absolutely fine as well. So let's first of all get rid of our update method because we're not going to need it. We will need start, but let's clear off our comment. And we're going to want to connect this script up to the TextMesh Pro element on the canvas. So at the top of the script, we're going to include a new using statement, and we're going to be using TM Pro. Then let's create a serialized field for our TextMesh Pro UGUI element and call this the score text. Let's also grab a reference to our scorekeeper and call this the scorekeeper. And then in awake, let's set our scorekeeper to find object of type scorekeeper. Finally, let's set our score text in start So we can say score text.text is equal to our scorekeeper.getScore. Now this is returning an integer, so we're going to need to turn it into text. We can do that like we did in our game scene by just adding the toString method. But if you remember, back over on our canvas, we also have this you scored part of the scoring message. So we can actually do away with this toString method if we want, because when we start concatenating strings and integers, the whole thing will get treated as a string. So let's add our little message of you scored. And to place our score on a new line, we can just use the new line character. So let's save this up and jump back over into Unity. Over on our canvas, let's take our UI game over script and drag over the score text. And if we hit play now, we should have a message of you scored 0. So that seems to be working. And the next step is going to be to convert our scorekeeper into a singleton. And this is going to be your challenge. I want you to turn our scorekeeper into a singleton. So if you feel up to taking on that challenge without any further advice, then go ahead and pause the video now. But if you want a hint, then take a look at what we did in our audio player for reference, because this is going to come in very handy for you. So pause the video now and give that a go. Okay, welcome back. So to set this up as a singleton, let's take a look at what we did for our audio player. We had a static audio player instance, and then in awake, we were calling our manage singleton method. This method was checking whether our instance was null. So if we weren't the first object to come along, then we were going to get destroyed. Otherwise, if we were the first ones to come along, then we're going to set the instance to this version of our audio player. So let's actually copy all of this. So our static variable, our awake method, and our manage singleton method. And then over in our scorekeeper, let's just copy and paste that into our code. And pretty much all of it can stay as it is. The only thing we're getting an error on is when we try and set our instance to this, because we're trying to set a scorekeeper into an audio player, which definitely isn't going to work. So instead, for our scorekeeper, we need a static scorekeeper instance. This will then get rid of our red error, and everything should work as expected. So let's save up our script and jump back into Unity. And if we go ahead and hit play, we should find that our score initially gets set to 0, which it does. And when we play again, our score is 0, but if we rack up some score before we die, so let's just get a couple of points, 100 is fine before we die. This 100 now gets carried over to our score. But we've now got a secondary problem that if we play again, we start off with a score of 100. So our next step is to work out when and where we want to call our reset score method. Well, if we head over to our script and open up our level manager, it would be a good idea to reset our score whenever we load our main game. So this script is going to require a scorekeeper called scorekeeper. And then in awake, we need to find this scorekeeper. So void awake, scorekeeper equals find object of type scorekeeper. And I'm sure all of this finding stuff in awake over and over again is really starting to tempt you into that public and globally accessible singleton pattern that we looked at last time. But with that set up, then let's go into our load game. And before we load the scene, we want to say scorekeeper.reset score. So whenever we load into our main game, our score will now be reset. So let's save all of our scripts and jump back into Unity one last time for some testing. Let's go ahead and hit play. And we're on the game over screen at the moment, so our score is 0. But if we play again and rack up some points, and we don't need to rack up many, we really just need the minimum amount of 50, our score is transferred over. But if we play again, our score gets reset. And with that, I think our game is pretty much there. We have a nice gameplay loop which we created with our different menus. Our score is nicely transitioning across from our different scenes and being reset at the right time. Our audio player is playing our music consistently through our levels. And really, the only thing left to do is to add some more content, so more waves, more enemies, more explosions, playtest our game, and finally build our game so that other people can play it. So congratulations on getting everything working, and we'll talk about some playtesting and balancing in the next lecture. So I'll see you there. Now that all of our core functionality is ready in our game, it's time to take the final steps of playtesting, balancing, and building our game. Before we jump into that though, we did add a bit of a bug in our last lecture when we were playing with our scorekeeper, because if we start the game now, when we click on our start button, nothing happens. Instead, we get an error message in our console and we're getting a null reference exception. So let's come out of play mode and fix this error. And one thing I want to show you with errors in the console is not only does it tell you what the problem is, so in this case an object reference is not set to an instance of an object, so it's trying to access something that doesn't exist. It will also tell you the script and the method that's causing the problem, and also the line where it's happening. And if we look at the stack trace down the bottom, we can ignore most of this, but we essentially read from the bottom up, and at the top it says that it's the level manager load level on line 18. And if we click on this link, it will open up our script and place us right at the problem area. So the problem here is we're trying to access a scorekeeper to reset the score, but there isn't actually a scorekeeper in our main menu scene yet. So the problem here doesn't really require a code fix. Instead, if we close our script, all we need to do is go to our prefabs folder, drag over our scorekeeper, and now if we hit play and test again, we should find that it works as expected. And it does, and takes us into our game. So with that small bug fixed, the next thing we want to think about is the balancing and playtesting of our game. So first of all, let's run through all of the scenes and have a think about what else we might need to add or change for each one. Our main menu is pretty much good to go. The only things of concern is the quit button, which won't work for certain platforms like WebGL. So if we're building to those platforms, we may actually want to go ahead and delete this button from our menu system. The other thing we need to think about is potentially adding a credits menu to our start screen. This would be as simple as adding a new button to our button group for our credits button, and then we could potentially link this to maybe a new canvas, which would overlay on top of the one we already have and would give us a nice place to give thanks to anyone that helped with the project or credit any providers of various assets we might have used. And with the knowledge you've gained from this section and previous sections, you should be able to implement that without any problems. So there are a couple of things to think about with our main menu. If we head over to our game over menu, I think this one is okay to leave as it is. It does everything it needs to and nothing else. But while we're here, one thing we may want to consider for both our main menu and our canvas is if we head over to the canvas itself and look down at our canvas scaler, we've given it a reference resolution and we've told it to match width or height, preferring the width. Now this is fine if we force our game to work in the 9:16 aspect ratio, but depending on some of our build settings and what the player is playing on, this could potentially run us into some problems. Because if we imagine this screen favouring the width and the player is playing on a 16:9 aspect ratio, we're essentially going to see this portion of the screen, which is going to potentially cancel out our quit button on our main menu and our main menu button on the game over, and it's all just going to look a little bit wrong. So a couple of options here. We could instead opt to favour the height of the screen, and this would then extend the sides of our screen, or we could go ahead and leave that as is, and instead force some of these settings in the project settings. We'll get onto project settings in a while though, so let's leave things as they are for now. It's just something to always be thinking about if you've tried to build your game and it all looks a bit strange. Try looking at the canvas scaler first, because that's usually, in my experience, the biggest problem with most of my projects. So finally, let's go over and look at our game. And in here, we've got a whole bunch of things that we can tune and tweak. So let's run through them in turn. The first one will be our player, and I've actually already gone away and done some additional balancing, so the values you see in this lecture will be different to ones from previous lectures. If we head to the player script, this was where we were controlling the speed of our movement and the constraints of the screen. So what I've done in here is just change the top padding. I've brought that up so that the player is constrained to the bottom half of the screen. Some other things we may consider is looking at our circle colliders. So if you're finding that your collisions look a little bit off when you're hitting projectiles or other enemies, then do be sure to go in and check your collider parameters for your offset and your radius. I think my health is mostly okay, although we may want to bump that up a little bit for a longer playing experience. And for my player, I thought the shooting was mostly okay as well, so I've left that as it is. However, if we then turn to our enemies, these aren't in our scene, but they are in our prefab folder. I've gone ahead and added a new enemy type. So I've done this by just duplicating my existing enemy. For each of my enemies, I've modified the health a little bit because I thought they were a little bit too difficult to kill. And I've also modified their score. So we can see that enemy 1 has a lower health and a lower score. And finally on here, for the shooter script, I've gone in and tweaked some of these parameters as well. There is no exact science though, and I definitely wouldn't recommend copying the numbers I've used here, because your game may look, feel and play in a very different way. Finally, on the gameplay front, we've got the waves and the paths. So rather than just the 2 normal ones I had before, I've created a bunch more with different configurations for the path look and feel. And I've also created a whole bunch of extra waves with different parameters and different enemies. And remember, once we've added more waves to our folder, we can add them to the game itself by going under the enemy spawner and filling out our list. The final things we really have the option to tweak is in our audio player, where we can control the volume of different aspects of our game. So we've got the music volume and the various special effects volumes. So again, try and balance these so that the music isn't overwhelming and in your face, and the shooting doesn't get too annoying if it's happening a lot. But with everything set up, let's play my game and just see how it looks and feels compared to the last lecture. So we start off with exactly the same 2 waves as we did before, but once they've finished, we've now got some new waves, new enemies, and different patterns that we now have to figure out. And because the shooting has changed as well, we now have a lot more challenge in the game. And I'm thinking that this may be a little bit too challenging. So again, it would be a case of going back in, tweaking those numbers a second, third, or even 4th time until we get something that plays nice, feels right, and will be fun for the player. And whilst we're on the subject of playtesting, it's worth remembering that as the game developer, you are inherently better at your game than anyone else is probably going to be. And as such, you're going to find the game much easier than it really is. So always revise your expectation of the difficulty down to make it playable for other people. This is also why getting external playtesters to help us out is important. With that said though, before we can give our game to playtesters, we need to build it so that we can share it. So the final thing we want to do is look at how to build the project so we can share it with other people. So the first step is going to be to come up to File and then down to Build Settings. And remember, this is where we came to place the scenes in our build. But now let's look at the bottom half of this screen with all of the build settings. Over on the left, we can select a platform to build to. And depending on how you set up your initial Unity install, you may or may not have some of these options in the list. At the very least though, you will have a PC, Mac and Linux standalone build. So from here, we could go and build our game. But I did mention we were potentially going to have some issues with the canvas resolutions and things like that. So the way we're going to fix those is if we head into our player settings, up at the top, we can set a whole bunch of information like our version number, we can set a company name and a load of stuff up there. But what we want to do is come down to our resolution and presentation, and we can just roll that out. And under here, we've got a whole bunch of parameters, most of which we can completely ignore. But the 2 of note are the top 2 here. So we can change the full screen mode and we can select things like full screen or windowed or things like that. And also the default is native resolution. So if we want to try and enforce some kind of resolution, we can uncheck this box and we can set a default screen width and screen height. So that's one way to help fix any resolution issues you might encounter. But rather than setting my game to full screen, I'm going to set it to windowed. That'll get rid of that checkbox option, and now we'll only have the option to set the screen width and height by default. With those options set up though, we can now come out of our settings window and back to our build settings. And to build the game, we just need to hit build. From here, we then need to select somewhere to build to. So in our Laser Defender project, let's right click and create a new folder for all of our builds. Let's call that the builds file. It doesn't really matter what it's called, but it's nice and descriptive. And then in here, we're going to have a couple of subfolders for the different platforms that we're building to. This first one is going to be the standalone build. So we'll select that as our folder. And now Unity will start building our project. Depending on the size of the project, this could take anywhere from a few seconds to a few hours. In this case, it didn't take too long. And now that it's finished, it's opened up our folder structure again, and we can see all of the files that are included in this build. So that's how to build a standalone version of your game. But when it comes to sharing with the wider world online, people don't tend to like downloading projects from unknown developers. So to make your game easier to share, let's head back into Unity and instead change our build to WebGL. This will allow it to be embedded in web pages so that players can play it without having to download anything. So let's click on WebGL and switch our platform. This can take some time depending on the size of your project, so I'm going to sit and wait for this to work and I'll be back with you in just a moment. Okay, my project has now changed over to be a WebGL build, and we can see that's the case with our little Unity logo there. But before we go ahead and build this project, there's another couple of things we want to fix with this build. So if we head down to player settings once again to load up our project settings window, in here, the top of the screen will be the same as it was before, but things like the resolution and presentation options will all have changed. So in here, we're going to want to set our default canvas width and height, and this came in by default for me as 960 by 600. This is actually a 16 by 10 ratio, and our game should really be 9 by 16. So let's go ahead and change our default canvas size, and we could go with a smaller scale like this one, so maybe 540 by 960. And if we head down to the publisher settings, we want to change the compression format to disabled, because a lot of sharing platforms don't like to have this compression in the build. So if we disable it, they can compress anything they need to on their end instead. With those two changes made, let's go ahead and close our project settings and then build our project. In our builds folder, let's create a new folder for our WebGL build. So we'll call this WebGL. And then once again, we just need to sit and wait for it. And while we're waiting for that to work, let's jump over to a site called sharemygame.com, which is run by gamedev.tv. And this is a great place to share your games and your prototypes with other members of the community. If you've never used the platform before, then the first thing you're going to need to do is to sign in or sign up. I've already got an account, so I'm just going to sign in with my Google account. If this is your first time signing up, then you'll be presented with a whole bunch of options for selecting your username, setting up profile pictures and all that kind of stuff. But once you're done, to upload a game, you can either come to the homepage and click on Upload Game, or at the top here in the corner, we have the Upload Game icon here. If we click on this, to upload our WebGL build once it's finished, we're just going to need to drag our entire WebGL folder into this box. My game has now finished building, so I'm going to click and drag that over, and it will prepare our upload for us. This may again take some time, but it's part of the process of getting your games out into the world. Once that's finished though, we'll get a congratulations message to say that it has been uploaded and is pending. We'll get a sample of our game so we can make sure that everything's working as intended. At the top here, we're also going to have the option to delete our upload if we wanted to. So if anything's wrong and we don't want to put this version up, we can delete this version, go back to Unity and make any tweaks we need to make, and then re-upload a new version. Finally, at the bottom, we're going to need to set up some parameters. Once we're done though, we can save our upload, and then that will take us through the remainder of the uploading process. And I think that brings us on to your final challenge for this section. I want you to go ahead and add more content to your game, so that'll include things like different enemy types, more waves, and if you're really feeling up to it, you could add some extra functionality like power-ups or things like that. I also want you to balance your game once you've added this additional content, so make sure that it all functions and make sure it's fun to play. And once you've finished balancing your game and you've had playtesters have a go at it as well, go ahead and share your game with the community and show off all of your hard work. Ask the community for feedback on your project, on what you could do better or what should be changed. And finally, pay this generosity forward from the community by reviewing someone else's game. Remember, we are all in it together and we're all still learning. So don't just post your game and expect feedback from others if you're not yourself willing to give feedback for their projects. So I look forward to seeing where you've taken your version of Laser Defender, and I'll see you in the next lecture where we wrap up and review everything we've learned. So I'll see you there. Congratulations on making it to the end of Laser Defender. You should now have a fantastic top-down shooter that you've not only finished working on in Unity, but also built and shared with the wider world. During this section, we've created a bigger project with more scene files included, and we've also fleshed out our gaming experience with things like music, sound effects, particles, and camera effects. We've also learnt how to create enemies at runtime and have them follow a set waypoint path through our levels. And over on the coding side, we've learned all about while loops, coroutines, and the singleton pattern. So congratulations again on making it to the end of this section, and I look forward to seeing all of your games that you're sharing with the community.
A huge congratulations, you have finished the content in this course. Now, if you're left there saying, oh, but I want more, not a problem. We've got so many other courses that you can dive into now. It might be the Unity mobile course you can dive straight into, or maybe the multiplayer course if you're feeling a little bit more advanced. We've got our huge RPG series, which is a really great place for you to get in there and really create something huge and substantial. We've also got our Unity 3D course that's similar to this course, but with a 3D flavor, where you can reinforce a lot of the concepts that we've been through in this course. And we've covered so much, all the way from the very beginner, here's how to click a button and here's how to create a variable, all the way up to a lot of more complex concepts such as coroutines, and the way we've been handling singleton patterns and creating a lot of enemies and just a whole bunch of stuff that we've done throughout this course. So you've learned a lot. The important thing now is that you keep practicing, you keep learning, you keep building more things so you can cement that knowledge and get even stronger and more awesome with your game development. So from the team here at Game Dev TV, thank you very much for joining us. Thank you very much for allowing us to be part of your journey, and I really look forward to seeing you in one of our other courses.